All right, here's the last example. Example 3. A ladder 10 feet long rests against a vertical wall. If the bottom of the ladder slides away from the wall at a rate of 1 foot per second, how fast is the top of the ladder sliding down the wall when the bottom of the ladder is 6 feet from the wall? All right, let's start with a picture. We're going to start with drawing our wall, the ground, and our ladder. Our ladder is resting against the wall. The bottom of the ladder is sliding away at a rate of 1 foot per second. Let's make the distance here for the bottom of the ladder, let's make it x. Let's make the vertical distance y. We know the ladder is 10 feet. That's our diagonal distance. Now, we can see that this is a right-angled triangle. So we know the relationship between the sides is given by Pythagorean theorem. Leg squared plus leg squared is the hypotenuse squared. In other words, x squared plus y squared is equal to 100. Now, we know the bottom of the ladder is sliding away at a rate of 1 foot per second. So we know that dx dt is 1 foot per second. We want to find how fast the ladder is sliding down. So we want to find dy dt. Specifically, when the ladder is 6 feet from the wall. That is, when x is 6 feet. All right. We know that x squared plus y squared is 100. Let's go ahead and let's differentiate this relationship with respect to time. We know the derivative of x squared with respect to time is 2x dx dt. The derivative of y squared with respect to time is 2y dy dt. And the derivative of 100 with respect to time is 0 because 100 is a constant. We would like to solve for dy dt. So we're going to move both 2x and dx dt to the other side. We see 2 dy dt is negative 2x dx dt. We're going to divide both sides of the equation by 2y, and we're going to get that dy dt is negative 2x over 2y dx dt. We see that the 2's cancel, and so we get dy dt is equal to negative x over y dx dt. Now, we are trying to find dy dt when x is 6. But note, the relationship here uses both x and y. So let's figure out the corresponding y value for when x is 6. Now, we know that if x is 6, that 6 squared plus y squared is equal to 10 squared, or 100. So we know 36 plus y squared is equal to 100, or that y squared is equal to 64, or that y is equal to 8. So we know that when x is 6 feet, y is 8 feet. So over here, when we try to find dy dt when x is 6, we are also finding it when y is 8. So we have 6 for x and 8 for y. That is negative 6 over 8 times dx dt, which we found or was given is 1. So negative 6 over 8 times 1 is negative 6 over 8, but reduces to negative 3/4. And then our units here are feet per second. So we would then say, well, how fast is the top of the ladder sliding down? The ladder is sliding down 3/4 of a foot every second when the ladder is 6 feet from the wall. That is all. Now see if you understand by trying this homework set.